Okay, in this video we're going to look at counting numbers of possible telephone numbers. We'll do example 5 here with early phone numbers, example 6 with our 360 area code, and example 7 count the number of possible toll-free numbers. So let's start with example 5, early phone numbers. So let's say this is quite accurate. In 1894, a town has only 2 digits for each telephone number and only uses the digits 2 through 9. How many different telephone numbers can be assigned to the town? Okay, and bear in mind that they did have letters in the phone number, but the letters always corresponded to a number anyway. And so essentially, for part A here, we have 2 options. If you have a telephone number, and you know they usually represent letters, but they went through as kind of numbers. And so essentially your options were, you could have the number 2, 3, 4, 5, 6, 7, or 8 or 9 in the first part of your number, and then again the number 2, 3, 4, 5, 6, 7, 8 or 9 as the next part of your phone number. So please press pause in the video and figure out, given that, how many unique telephone numbers can you create? Okay, I hope you press pause and give it a go. I'm going to help you with it now. So for example, you could take the number 2 as the first digit in your number, and then onto that you could add a 2, or you can go 2 and then 3, or 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9. Okay, and that gives us 8 options. Okay, starting with 2. And then if you start your number with 3, you'll find there are also 8 options. Right? Because it's 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, 3, 9. 8 options starting with 3. How about starting with 4? Same thing again, right? There's going to be 8 options, isn't there? Because it's going to be for 2, for 3, for 4, 5, for 6, for 7, for 8, and for 9. So 8 options again, and so on. And starting with 5, there's 8 options. Starting with 6, there's 8 options. Starting with 7, there's 8 options. Starting with 8, there's 8 options. And starting with 9, there are 8 options. Okay? And so the answer is, if you listed them all out, and I didn't list them all out, but we would have 8 options here, 8 options here, 8 options here, 8 options start with 5, 8, 7. Okay, and if you just add them all up, 1, 2, 3, 4, 5, 6, 7, 8. 8's 64 options. Okay, and that would be the answer to part A. So that's kind of the writing it out way of doing it. And it's always good to do that, especially if you want to just try to get a visual, or if you're stuck or whatever on a question. But there are 8 possibilities in the for the first digit, and there are also 8 possibilities for the next digit, because remember 1 and 0 are not included. Then you can actually multiply, because an 8 times 8 will give you 64 by multiplying also, won't it? Right? So but I really want you guys to kind of think and understand what's going on, rather than just memorizing methods or whatever. So part B, by 1902 the town has more phone users than 3-digit telephone numbers are used. If they still only use digits 2 through 9, how many different phone numbers are possible? Okay, so this time you've got 3 digits. And what I want you to think about is, we almost listed all 64 of the possible phone numbers, like 22 or 47 or whatever. It could be 92 or whatever. So we almost, 52, 62, 72, 82, right? And this went all the way down through 59. This is a phone number at 59, and this one went all the way down through 69, and so on. And this one went all the way down through 99. Okay. So what I'm trying to say is 7989. We almost listed 64 different phone numbers. Okay. That had 2 digits in it, right? But if you add on a third digit to a phone number, what I want you to understand is you can take any one of those, like randomly, let's take this phone number 45, any one of those, and you can add on another digit like 2. But you can also go 45 and then add on a new digit of 3, and that's another one. So for any of these 2-digit phone numbers, there's actually 8 new ones that you can create. And so let me list them here. So for the phone number 45, back in the 19th century, for the phone number 45, just by adding one more digit, you can create 8 new phone numbers. This is 8 new phone numbers. Okay? Using the digits 4, 5. 4, 5 something gives us 8 new phone numbers. And so that is the key to understanding this. And you can do that for any 2-digit phone number. Like if we take, for example, the phone number 89, right? We could do the same thing. So if the first digit was 8, the second digit was 9. I'll list them all out here. You could go 892, 893, 894, 895, 896, 897, 898, 899. And that is taking a 2-digit phone number 89, adding on 1 digit to it to create 8 more new phone numbers. So for every one of these 64-digit phone numbers, we can create 8 new 3-digit phone numbers. And so the way to get the answer to this, how many different phone numbers are possible if you're using 3 digits and you're using just 2 to 9, not 0 and 1, the answer is 8 times 8 was 64, wasn't it? But times 8 again, that's 512, isn't it? So just by adding on another digit, we've gone from 64 phone numbers to 512 possible phone numbers. 512 possible numbers. Okay. So please do part C. Let me get new paper, I guess. Part C. By 1911, the town has more phone users and 4-digit telephone numbers are used. If they still only use digits 2 through 9, how many different phone numbers are possible now? So please press pause on the video and do part C. Okay, I hope you press pause in the video. I'm going to do it now. So again, this time we've got 1, 2, 3, 4 digit phone number, but only using digits 2 through 9, not using 0 or 1. And again, the same logic applies as we talked about. You can take any 3-digit number, like we could take the 3-digit number 2, 3, 9, and then we can add on another digit, and that is 8 new numbers. So for every 3-digit number, we can add on another digit to create 8 new phone numbers. Okay? So for example, I'll just write them out. If you had 2, 3, 9, like I said, that could be 2, 3, 9. Whoops. that could be 2392, 2393, 2394, 2395, 6, 7, 8, or 9. So for any 3-digit phone number, we add on one more digit, and that's 8 new numbers. See that? 8 new numbers, right? So there were 512 3-digit numbers, and for every one of those 512 possible 3-digit numbers, we can now get 8 new 4-digit numbers. So we simply take 512 and multiply it by 8, and that's our answer, 4,096. 4,096 possible 4-digit phone numbers. So 4,096 new users by 1911. And the other way, and the kind of formula way, I guess, is you just go 8 times 8, 64, times 8 again, 512, times 8 again, 4,096. But really hope we can think about this and understand why rather than memorizing what to do. Okay, so example 6, 360 phone numbers. The 360 telephone area code is used from Washington's Canadian border to its Oregon border, and there's a map on that. It's, Western Washington, excluding Seattle and most Seattle and things like that, or parts of it. After 360, each phone number in the area has 7 digits from 0 to 9. Ignoring any restrictions like I don't think there's such a thing as 0000000, or maybe all ones in a row or whatever. How many possible phone numbers are there? So we'll just keep it simple, and we can say that you're going to dial in 360, but then you're going to do 1, 2, 3, 4, 5, 6, 7 digits after that. How many 360 telephone numbers are possible? Please press pause on the video and try and answer it, and then I'll go over it with you. Okay, I hope you've pressed pause and tried it yourself. Now we'll go over it. So remember that this is modern phone numbers, so we can use digits 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. How many digits is that? That is 1 through 9 and a 0. That's 10 possible digits for the first part of the phone number. The first digit in the phone number, there's 10 possible, right? And so that means the first part of the phone number could be, for example, 0. Well, it could start with 0. So it could be 01, 02, 03, 04, 05, 06, 07, 08, or 09. In fact, I'm not sure if that is possible, but just from a math point of view, just to get an estimate, we're just going to estimate the possible numbers. I'm not actually sure of the technical restrictions on phone numbers. It could start with 1, so it could be 11, 12, 13, 14, 15, 16, 17, 18, or 19. Okay, and so on. Right, so for the first 2 digits, how many possible options are there? If we just looked at the first 2 digits, let's start there. If you just look at the first 2 digits, how many possible options are there? 21, 22, 23, 24, 25, 26, 27, 28, 29, and so on, all the way through starting with 9. So 91, 92, 93, 94, 95, 96, 97, 98, 99. So just looking at the first 2 digits, I hope, I didn't write them all out, but I hope you might be able to see that there are actually 100 possible options just for the first 2 digits, because there are 10 options beginning with 0, 10 options begin with 1, 10 options begin with 2, 10 options begin with 3, 10 options begin with 4, 10 begin with 5, 10 begin with 6, all the way through 10 begin with 9, to make 100 options just for the first 2 digits. Agreed? Does that make sense? 100 options just for the first 2 digits. Okay? But now, and the quicker way is, well, 10 times 10 is 100, right? But then going on to the next digit, for looking at 3-digit numbers, the thing about it is you could take any one of those 2-digit numbers, like this one, 24. You could take 24. Sorry, 24. That's a 2-digit. That's the first 2 digits in the phone number, 24. And on to 24, you could add 10 possible numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So you can take any of the possible 2 digits to begin with, add on 10 options more. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So 240, 241, 242, 243, 244, 245, 246, 247, 248, 249, and that is 10 new possibilities that start with 24, right? And you can do that for every single 2-digit beginning. So the beginning part number is 2 digits, and you can add on to get a 3-digit number. There are 10 for every one of those. Okay, so for example, 9, if you just pick randomly 9, 6, 9, 6 something, there are 10 options, right? Or 1, 7. 1, 7 something, there are another 10 options, right? So what I want you to understand, without just multiplying things out, just to understand that for every 2-digit option, you can pluck it out and you can stick in a digit at the end of it, and now you have 10 new options for 3-digit phone numbers. And that's why when we go to 3 digits, we actually get 1,000 options for the first 3 digits. Does that make sense? So 3 digits gives us 1,000 options, right? 10 times 10 times 10 is 1,000. For the 4th digit of the phone number, you know what I'm going to do. I'm going to take any 3-digit option, like 245, and I'm going to add on another digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that's going to give me, for every 3-digit option, of which there are 1,000, that's going to give me 10 new ones. So picking any 3-digit option, I can add on any digit from 0 through 9, and that gives me 10 new options for 4 digits, right? So here's another one. You could have 899 and then add on another digit, and that's 10 new ones. And so for every one of our 1,000 3-digit options, we can add on a digit to get 10,000 options for 4 digits in a row. Okay? And so here's our phone number, 360. And for the first digit, 10 options, 10 options, 10 options, 10 options. Now we're up to 10,000. And it just keeps going. And of course you can multiply that, but just to understand it, 5 digits. Take any random 4-digit option, of which there are 10,000, remember, such as 1, 3, 1, 7. And add on one more digit. There are 10 options, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so for every one of our 4-digit options, we can add on a digit at the end. And so we can get 10 new options for every 4-digit, right? So we can take any one of our 10,000 4-digit options, add on a digit. Now we have 100,000 options for 5 digits in a row, right? 100,000 and 6 digits similarly. Take any 5-digit option like 2, 3, 9, 4, 1. Add on another option at the end for a 6-digit number. And now for every 5-digit number, we can add on for every 5 length of 5-digit number, we can add on a digit at the end, 0 through 9, and get 10 new numbers. So for every 100,000 options of 5 digits in a row, we add on 1 digit. Now we have 1 million options for the 6-digit number. Okay, and how about a 7-digit number? For a 7-digit number, same thing again. we can take any 6-digit number like 9, 7, 3, 4, 1, 2, and we can add on another digit that ranges from 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Add it on, and now for every million 6-digit possible sequence of numbers, we can add on a digit, and that will give us, for every one of those 6-digit numbers, we can get 10 new 7-digit numbers. Okay, so we can take any one of those million 6-digit options, add on a digit, and now that is 10 new ones, so 10 million. Possibilities here, or options, right? Or numbers, whatever you want to call it. So, for how many possible phone numbers are there if we ignore restrictions on what the numbers need to look like? The answer is 10 times 10, 7 times 10 to the power of 7, or 10 million, right? 10 million possible 360 phone numbers. Okay. So on to example 7. As of 2017, there are now 7 possible prefixes for toll-free numbers: 800, 888, 877, 866, 855, 844, and 833. Ignoring any restrictions, how many toll-free telephone numbers would be possible, right? So let's start with 800. After 800, there are going to be 7 digits. Agreed? Okay. So just tell me to begin with, and then I'll ask you to finish the question on your own. But tell me to begin with, how many possible phone numbers can we have that start with 800? Ignoring any restrictions, like it can't all be the same digit in a row, like 333, 3333, or whatever. And there's probably restrictions like that, I'm sure. But ignoring those, how many possible phone numbers can we have begin with 800? If there's 7 digits after it. So the answer is exactly the same as what we just went over in the previous example. Okay. If there are 10 options for each place, for each digit spot, we can just multiply 10 times itself 7 times to get 10 to the power of 7, or 10 million. So that gives us 10 million possible phone numbers starting with 800. Okay? So you might want to press pause and see if you can get the rest of the answer to this question. Press pause and see if you can get the rest of the answer. Okay, I hope you pressed pause and tried it. I'll do it now. So just got to think about the next toll-free number, 888. After that, there are 7 possible digits after that, right? And just like with 800, that gives us 10 to the power of 7, or 10 million options for phone numbers beginning with 888, right? How about 877? Exact same thing, 10 million options, right? How about 866? 10 million options again. Agreed? How about 855, 844, and 833? Again, 10 million options, 10 million options, 10 million options. 3, 4, 5, 6, 7. And just as a tiny factoid, I think there's about 120 million phone numbers in the USA. So that gives us 70 million possible toll-free numbers using these prefixes.